Okay, this time we have a related rates problem that's going to deal with an angle. Okay, so a man is walking along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. So this guy's walking along a path. The rate at which he's going along this path is 4 feet per second. There's a searchlight that's 20 feet from the path, so I'm going to make it just come straight down here. This is going to be 20 feet away. And here's our spotlight right here at the end. So as the guy walks along this path, this spotlight stays focused on him. So I just kind of imagine this problem as being maybe this guy is trying to slowly escape from jail or something, and they caught him, as you see in the movies, and then the spotlight. I know there's a Austin Powers movie where that spotlight just keeps following him the whole time. So he's walking away. The spotlight stays focused on him. So this angle of this spotlight is going to turn based on where this guy is at any point in time. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? 15 feet from the point on the path closest to the searchlight. So, and it's maybe kind of difficult to understand what that's saying. So, anyway, this light is turning at some angle. I don't know what the angle is at that point in time. And I want to know when his position is 15 feet from the point on the path closest to the searchlight. So the point on the path closest to the searchlight would be here. That's whenever the light is just directly underneath the path, and that's always going to be the straightest or the closest that he gets. As he walks this way, he's obviously further away from that spotlight than what he was here. So basically, when this is 15 feet, what rate is this spotlight rotating? At what rate is that changing? So what I'm trying to find, if I'm trying to find a rate of rotation, that is going to be a d theta dt. That's going to be a rate at which an angle, the change of the angle and change of time, the rate at which the angle is changing. Okay, so because of that, even though it's a triangle, you do not want to use the Pythagorean theorem here. And I say that as my main function. I don't want to use the Pythagorean theorem. I want to use some kind of function that relates this angle with these side lengths that I have. So if this was the right angle up here, because I drew this line straight down from that point. Think about the trig function that you would need to relate this angle with these two side lengths. Okay, I don't have the hypotenuse, I have the two side lengths. And hopefully if you think about that long enough, you would come up with tangent. The tangent of the angle is equal to opposite over adjacent, right? Tangent is opposite over adjacent. So that's going to be opposite, and I'm just going to call this length x, I'm going to call this length y, and we'll call the hypotenuse z. I'm not going to need that for a while, but opposite would be x, adjacent would be y, tangent of theta equals x over y. Now, this y value, I can go ahead and replace that with 20, because this spotlight is staying 20 feet away from this point nearest on the path to that spotlight. So this I'm going to replace with 20. I don't need to worry about that being anything other than 20. So now I get to the tangent of theta has to equal x over 20. And what I'm going to do is I'm going to multiply by 20. This is just going to make it a little bit easier. So that I have x equals 20 tan theta. I've only got two variables. That's great. I know the rate at which x is changing, right? He's moving along that path at 4 feet per second. So I know that rate, and I'm trying to find the rate at which the angle is changing. So we're good to go. We can go ahead and take the derivative. So dx dt is going to equal 20. Derivative of tan theta is secant squared theta times d theta dt. Okay, and again, I'm trying to find d theta dt. I've got some of the information for the other things that I need. There's going to be one little part that I don't have that we'll have to find. So, what do we have? dx dt, we know that's 4. This is 20. This is secant squared theta. Do I have the angle theta at the time that he's 15 feet away? Well, right now I don't. So I'm just going to have to leave that as secant squared theta. And I'm looking for d theta dt. So the problem here is, or what I need to find in order to find d theta dt, I've got to figure out this theta, either the theta or the secant of theta, which is what we're actually going to do. You're going to see that you don't actually have to find the angle to solve this problem, as long as you know your SOHCAHTOA relationships. You don't ever have to do inverse trig function to find the angle or think about your unit circle. You do not have to do that. You can. That's possible, but you don't need to. So I'm going to kind of come out here to the side and say I need secant theta. So what is secant theta? How is secant theta related to the trig functions that I know better than secant? Secant is equal to 1 over cosine. It's the reciprocal of cosine. And cosine, I know by SOHCAHTOA that cosine is adjacent over hypotenuse, which means the reciprocal of that, secant, would be hypotenuse over adjacent. And so if I'm looking at this angle, I've got the adjacent side. The adjacent side is 20. What I don't have is the hypotenuse. And I'm going to have to find that. And in order to find that, that's why they have to give me at the time at which he's 15 feet away from that point. So I've got those two things. I can find when he's 15 feet away, I can find what the hypotenuse would be at that time by simply using the Pythagorean theorem. So z squared would be 20 squared plus 15 squared. And if I take the square root of that, that's going to give me a z value of 25. So when he's 15 feet away, this is 25, which is going to help me with this, because now secant theta, not just secant theta, again, incorporating the angle here, I don't need to find the angle because secant theta is hypotenuse over adjacent, which is going to be 25 over 20, which I'm going to reduce to 5/4. So that is secant theta. Secant theta is 5/4. And remember, this square just means I'm squaring that whole thing. So I'm going to go from here, I'm going to say 4 equals 20 times 5/4, that's secant theta, squared, because of this, times d theta dt. Okay, now I've got everything except for d theta dt. Notice I never had to find what that angle was. As long as I know the trig relationship, I don't need the angle. So now it's going to take me up here where I have 4 equals 20 times, if I square 5/4, I get 25/16 times d theta dt. I'll go ahead and divide by this 20. So 4 over 20 is going to reduce to 1/5. 1/5 equals 25/16 times d theta dt. I'm going to multiply by the reciprocal here, 16 over 25, cancel that out, multiply this by 16 over 25. 16 over 125, perfectly fine answer for d theta dt, as long as you give me a unit. If you would like a decimal to maybe make it make sense, this is going to be 0.0128. And anytime you're dealing with an angle and it doesn't say degrees, we're going to say radians. This is a radian measurement. It's a rate that is changing in terms of radians per second. The time element was seconds. So 0.0128 radians per second will be the rate that angle is changing. So I think a lot of people, when you're learning related rates, they have the most trouble with the angle ones. So, just keep that in mind. Coming up with this function, hopefully that wasn't too bad, as long as you know your trig relationships. Okay, that's going to be the important part to do that problem.